Well, hello, my Algebros. This is our final study guide, literally the study guide for the final video. So on chapter 1, we remember that we were learning all of our pre-algebra skills, which are knowing PEMDAS, parentheses, exponents, multiplying, dividing, adding, subtracting, orders of operations when we evaluate expressions. And number 1 is in evaluating P minus Q when P is 12 and Q is 5. And we have to really watch our negative there. So 12 minus 5 is 7, right? That's just evaluating expressions. But the rest of this page is solving. And when I solve, I go backwards. SADMAP. I see if I can subtract or add anything first. Then can I multiply or divide anything? And then I resolve any exponents and parentheses. That's if I'm solving for a variable, not evaluating for one side of a equation, which we'll see in a little bit. So number 2, I have to use my inverse operation of adding 32 to both sides. Getting y is 100. And number 3, all I have to do is use an inverse operation. Again, I am in the first 2 steps of SADMAP, subtracting or adding anything to isolate the variable and solve for it. Number 4, I divide, and I have to remember that dividing and multiplying is when I'm doing products or quotients, that a positive and a positive is always a positive thing, like relationships, and a negative is also a positive thing, but a positive and a negative collide and cause a negative thing. Where when I'm combining like terms, if I have added negatives or positives, then it's like money. Whatever is the most of, anything negative is something you owe, and anything positive is something that you earn. Okay, on number 5, I have to use my inverse operation of multiplying, and I get z is negative 70. And number 6, I have to use my inverse operations, our first 2-stepper. I first SAD, I S and I A. I have to add first, and then I divide by 6. And then number 7, I have a sentence that I have to figure out which one is the right one. It says 8 less, and as soon as I know that it's 8 less, then it has to be a negative 8, so I know that A is correct. 8 less than a number, and we're going to use n for a number, is, and that's equal to negative 12. Okay, number 8, I have to evaluate expressions first, right? I have to PEMDAS, combining my like terms, and then I can solve by dividing or isolating my variable using the inverse operation, right? PEMDAS first before I can SADMAP. So I'm going to go ahead and evaluate my expression before I can isolate from my variable. So I have to distribute using parentheses, and then I combine my like terms, and now I can finally solve isolating my variable using an inverse operation, right? Or SADMAPing. Number 10, I have to get my variables on the same side. Anytime I go over the equal sign, I have to use an inverse operation, an opposite operation. On number 11, I first need to PEMDAS before I can SADMAP, so I have to evaluate the expression, and then I go across the equal sign using inverse operations, and I finally reduce the fraction negative 6 over 10 to negative 3 over 5. Okay, number 12, we finally see our first very linear equation. But we don't talk about linear equations yet, but we do know, just a little peek, that y equals mx plus b, where m is my slope or my constant change, my constant fee or whatever it's going to be, or miles, and b is my initial cost, right? And y is always the money. So we have truthful Tom will charge $50 an hour plus $200 for a part to fix Tia's car, where Fair Fred will charge $40 an hour plus $250 for that part, right? Because T is the value or the cost for Truthful Tom, and F is the cost for Fair Fred, we technically know that these are both y equals because y is always the cost. And because of that, we can substitute one value in for the other to solve to see when they would be the same, right? So I go ahead and set them equal to each other and solve for how many hours it will take. Isolating my variable of hours using inverse operations, I find that it's in 5 hours. These two jobs will cost the same. But how much will they cost, right? Well, if I put in 5 hours for the first one, I get that it's going to be $450. And if I put 5 hours in for the second one, it is also $450. So I know I did this problem right, that in 5 hours, they will cost the same, which happens to be $450. On 13 and 14 and 15, we are talking about absolute value, and absolute value is all about the distance from zero, right? So we have two ways we can go from zero on a number line. We can go positive numbers and we can go negative numbers. When we talk about the absolute value of something, it is the distance from zero. So the absolute value of, say, 3 would be 3 because it's 3 places from 0. As well as the absolute value of negative 3 is also 3 because it's still 3 steps away from 0. So we have to set these two equations to equal how many steps they could be from 0. Well, when we say what they could be, we know that inside it could be a negative or a positive. So we have to write two different equations and solve for both using at the beginning of our chapter 1 skills of isolating for a variable. But in order to know, we have to check and make sure that they actually work. So we plug them back into the original equation and we check our solutions to be sure that we actually solve for it correctly, right? On 14, before I can solve this, I need to isolate my absolute value. So I subtract 6 from both sides. And then I can make my two equations, right? Then I can make my two equations. Once I do that, I solve for my variable and I check it. Excuse me. Showing that, yes, both 6 and 0 work for this. On 15, it asks us a couple word questions. An absolute value is always a non-negative. Well, that means it has to be positive steps, right? Because it's a distance. You can't have steps that erase themselves, right? So we say they are always positive numbers. And then absolute value has two equations. Well, sometimes you have to check it to see if the solutions work. On 16, we're going to set up this ratio of what we have. It tells us that we have a ratio of girls to boys. So girls 2, and 2 is the division symbol, to boys, right? And then we say that that is 3 to 2. And what else do we know? Well, we know what the boys are, and we're solving for the girls. At this point, it's a proportion, so I can cross multiply to solve. And I find that the girls are 27. On 17, it's also a ratio of donuts per minute. Donuts per minute. And I know it's 72 donuts in 45 minutes. And then I just divide because we want to know how many donuts per minute. And I get 1.6 donuts per minute. 18, we have a proportion, but now we have it more that we're working on our algebra skills because we can see that we have families that we are distributing to. So when I multiply across, I have to distribute to the entire family before I isolate my variable and solve. And the same with 19. I have to cross multiply, making sure I distribute to the entire family before solving for my variable. On 18, we have a shape, and we know that we can match the shapes because it says that they're similar right here. It says that they are congruent, which means that sides are proportionately accurate to each other no matter what the numbers look like. So we know that 8 is going to be proportionate to 24, and 3 will be proportionate to y, and then we can solve again by cross multiplying. And that brings us to chapter 2. On chapter 2, we need to read and write things from the variable's perspective. So we know that n is less than -2, or we can rewrite it so it's from the variable's perspective. So we know it's all real numbers less than 2. Why do we say all real numbers? Because there's this thing called imaginary numbers that we're going to talk about more second semester. On number 2, it says choose the inequality that best represents the sentence. An essay must be at least 350. And so what you need to ask yourself is can it be 350? Well, yes, it can. But can it be more than 350? Well, yes, it can, right? It doesn't say it cannot be any more than, and then we would have to say it's less than or equal to. On 3 through 7, we need to isolate our variable and then graph it. And because inequalities represent a set of solutions, right? So for 3, we find that x can be bigger than 18. It cannot be 18. That's why it's an empty circle, but it's bigger than 18. And for 4, x is greater than -6. For 5, we have the first time we're multiplying or dividing by a negative coefficient, which means we have to switch the sign in order to tell the truth, right? Because when I multiply by a negative number, I change the value of the equation. So I have to switch it. And the same thing with number 6. I have to multiply by a -4, so I have to change the sign. And number 7, I have to PEMDAS before I can SADMEP, so I have to evaluate both sides of my expressions, and then I can isolate x. Getting x is less than or equal to 14. Number 9, I have to get my variables on the same side using inverse operations. Once I do this, I can finally SADMEP to solve. Number 9, I have to first evaluate an expression again, reminding ourselves we have to PEMDAS before we can SADMEP. And the same with number 10. When I do this one, though, I notice that there's the similar value of a variable on both sides. So I want to eliminate that variable, subtracting 10p from both sides to see if this sentence is true or false. When you have the same variable value on both sides, it is either going to be true or false, which means it's infinite many solutions. Anything I put in for the p-value will work, or it's no solution, nothing will work. And in this case, we see that it's a true statement. -10 is greater than -12. So the solution would be that it's infinite many solutions. On number 11, we also see that it has the same value of the variable. And when we eliminate this, we see that 12 is greater than or equal to 20. Well, that is not true. So we know that this is not a solution. There is nothing I can put in for y that will work. 12, we have some word problems on this page. So it says the average of Paula's 2 test scores must be a 90 or more. We need to know how to solve for an average. An average is when we add up a total of something that we're trying to find the average of, and we divide for how many things we added up. So we have 2 tests, so we divide by 2. What else do we know? We want this to be greater than or equal to 90 to get an A. What else do we know? We know that the first test is 90, so we don't have to say the second test. We're just solving for the missing test. And we do this by isolating our variable using our inverse operations. We multiply by 2, and then we subtract 93. Getting that test has to be greater than or equal to 97. On 13, we have Jasmine and her sister that are saving up for an MP3 player, and we know that Jasmine has $40 and is saving 10 a week, and her sister has $60 and is saving 6 a week. And because this represents how much money they have, we know it's literally the cost of each one. We can substitute them in for each other, And in this time we're using an inequality, so we want to see if Jasmine when she will have more than her sister, isolating our variable and finding out that she'll have more in more than 5 weeks. So our answer is 6 weeks because that is more than 5 weeks. 14, we need to read and write this out. It says the difference of 5 and 4 times a number is greater than or equal to -7, and then we isolate our variable. On 15, give 2 solutions for this. Well, first you have to solve. And 2 solutions, because it says that x is greater than 6, 2 solutions could be 7 or 8 or anything more than that. And non-solutions would be 6 because it has to be bigger than 6. So 6 is not a solution, or 4 or 5 and so forth. 16, we're graphing from the variable's perspective. Our circle represents the variable right there. And so we know that this is x is less than 4. 17, we have to isolate our variable first. And because there's 2 inequalities, when we isolate the variable, we have to do the inverse operations to both sides. So first we subtract 9 from both sides. Then we divide by 5 for both sides. Finally, isolating our variable, find that a is less than 4 and a is greater than or equal to -1. And we graph this correctly. On 18, there are 2 separate inequalities, so we can solve for one, then solve for the other, and graph both. 19 and 20, we are looking at the graph and writing what it represents. So remember that x represents this value, and it also represents these 2 values. On 21, we're checking to see if a solution fits into an equation that's an inequality. So again, we see if the solution is true or false. So we know the x and y value, we substitute those in to the equation that's been given to us, and we see if it's true or false. And we can see that -4 is less than 9, so it's true. This is a solution for this equation. The same thing we check on number 22. The first works, and the second also works. And because it works for both, then yes, it is a solution. On 23, we're graphing this set of solution using y equals mx plus b. And we start with -3 as our y-intercept. And we do a dashed line because it's not equal to. And our slope was up 2 and over 1. And then we have to decide which side of this line holds all the solution points. Well, I can see the equation says that y is bigger than -3, so I know it's everything bigger than -3 that needs to be shaded. And I could do a test point if that works better for me. And if I just choose any point that's not on the line, like 0, 0, and plug it in, I can see that this is true. So any side with that point would be true because they're all those sides. Every point on that side is a solution. And on the other side, they're not solutions. So on 24, I'm going to go ahead and graph. And I shade in the true side. I graph the second one. And this is a dashed line, and I shade the correct side. And where they doubly cross over each other, blue and pink make purple, and that's the shared solution set. Okay, I'm going to stop here and make a separate video for the second half because this one's getting pretty long. Okay, so that's chapters 1 and 2.